Okay, before we give look at a specific example, you just want to remember a couple of key things here. Logarithms reverse exponentiation. Okay, so these guys are interchangeable. If you look at the laws of indices and the laws of logarithms, they are there are equivalent log laws that are equivalent to an indices law. So this is something that's written in log format. So you have a base, you have a number, and on the far side you have a power. Okay, so the base in the log case, the power is the piece of that jigsaw puzzle that is on its own. Alright? Whereas in exponential form, the base has a power and the number is on its own. So depending on your needs or your situation, you can switch between each format, especially when you have an unknown like an x variable that you need to find. If you can get that x on its own, whether if it's a power that's an x, well then a log format is going to suit you. If it's a number, well then an exponential format is going to suit you. We'll just look at an example here. So you have this 3 squared equals 9, and that's in exponential form. If I wanted to transfer that into log format, you take 3, because if we reference up here, 3 is going to be my base. Alright, so log base 3. Okay, and then you go across here and you pick up the number. Okay, so we're going to put that here, number. So remember, the log format is the base, the number, equals the power. So then you finish off by putting your power over on its own. Okay, so that would be useful if you had a situation where you had 3 to the power of x equals 27, for example. Alright, and you couldn't figure this out, or if it was a more complicated example, you could switch that to log format. Log base 3 base to power equals x. And then the left hand side you can just key into your calculator and you get your answer for x, which is 3. So the logs allow you to work these things out, whereas you might have great difficulty if this number is quite large. 27 was different, that is not so easy to figure out. It allows you to manipulate things to your advantage. Okay, so we just have to remember being able to switch between these two when we move on further into the questions. Okay, so the first question we're going to look at is this. We have log base 3 of 2x plus 5 minus log base 3 of x minus 8 equals 1. Okay, the first thing to note here is that the base numbers are the same. Okay, base numbers are the same. So if we just reference our laws of logs, okay, and these are in your maths tables, okay, see there, maths tables page 21, which you'll have in an exam. So law 2 states that if you have two different terms, x and y, but which have the same base number, well then you can switch back. So if you have the right hand side here, which we do, we have two separate values being taken away, same base numbers, we can change it into a quotient or a fraction, which is 1 log to the base number that's common. So that basically means in our situation here that we can, rather than having two separate logs, two separate logs, we can just write down 1 log base 3 and take the first number, or first term, which is 2x plus 5, and put that over x minus 8. Alright? And that's all still equal to 1. So we have log base 3 of 2x plus 5 over x minus 8 equals to 1. Now if we reference back here, we have this situation up here. We have it in log format, and we can see our base is 3, Our number is 2x plus 5 over x minus 8, and our power is 1. So we take our base, 3, we put it to the power of 1, and we let it equal to our number, which is 2x plus 5 over x minus 8. Okay? Now it's just an algebraic equation now that we just have to solve. Alright? So we won't go through all that, but you end up with a situation where you have 3x minus 24 equals 2x plus 5, so that leaves x equals 29. Alright? And that's it solved. So the only new thing in terms of logs is your laws of logs to switch this first line into this, and then your kind of basic principles of logs and exponents, how to switch between the two formats. That allows you to separate out the log from these x's which you don't know. So this is the value of this, of being able to switch between exponents and logarithmic formats. The base 3, the power 1 equals this, and that allows you to get back into the situation here where you can now go and work out x. So x equals 29. Okay.